Hello. Now we are going to look at triangles and parallelograms and particularly at their areas. So we're going to start off with the area of a triangle, and we know that the area of a triangle is half of the base times the perpendicular height. So we're going to have a quick moment to look at that in some more detail. So a base is going to be any of the sides of our triangle. So here I have the bottom side of our triangle as the base, and then the perpendicular height is the right angle height. The perpendicular means just at right angles, so the perpendicular distance out from that base to the far corner. Now I've drawn exactly the same triangle here, and if I took this side as being my base, then I would go perpendicularly at right angles out to the far corner to get the perpendicular height. So this dashed distance here is the perpendicular height from that base. So anytime we want to get the area of a triangle, we need to be careful that we know the right angle distance from the side we're using as the base out to the far corner. And it can be any of the sides, but we need to know that perpendicular height, that perpendicular distance from that base. If we have a right angle triangle, that's often very easy. If we have non-right angle triangles, we have to be quite careful. So that's our triangle area, and it's in our log tables, half the base times the perpendicular height. Now if we look at a parallelogram, where we just have sides that are parallel to each other, and the opposite sides are also equal in length to each other, that's what a parallelogram is. The area of that is the base times the perpendicular height, which we can see is just twice as big as the triangle, and we'll see why that is in just a moment. But again, any of the sides can act as the base, and then we need to know the perpendicular or the right angle distance out to the parallel side on the opposite side. So I can use the slanted side as the base as well and go out perpendicularly from that at right angles from this base, from that side, out to the parallel on the other side, and that right angle distance is my perpendicular height. So I need to know the base and the perpendicular height in both cases. Now the reason why this formula looks like I've just doubled the triangle formula is because that's exactly how we get the parallelogram area formula. If we draw a diagonal line, either of the diagonals, through our parallelogram, we get two equal triangles. So if I take this bottom line here as the base, then the perpendicular height up from that base, if I drop down here, that perpendicular height, so base times the perpendicular height, well, half the base times the perpendicular height would give me the area of this lower triangle, and this triangle is exactly the same, so I have two halves makes a whole. So that's where my formula for half the base times the perpendicular height is coming from for a parallelogram. It's just double the triangle formula. That's all it is. So that's how we get our two formulas, and we can use these in lots of different contexts, being careful about our bases and our perpendicular heights. So if we jump into our triangle question here, we have lots of information for this diagram. I can see I have one of my sides is 14, and the perpendicular height away from that can sometimes be labeled off to the side, as I've labeled it here, and that perpendicular height from the base of 14 would be 8 units. And I see I have another side here, so I could use this as a base as well if I knew this green perpendicular height here. So I look at my diagram and I see the information that I'm given, and that gives me context for where this is going to go. So I'm asked for the area of this triangle. Well, I know a base and I know a perpendicular height, so I can immediately write down the area is going to be half of the base times the perpendicular height. The area is what I'm looking for. Half is just a half. The base would be 14 if the height was 8. So the base I'm using is 14 units long, and the perpendicular height away from that base would be 8 units, the blue length here. So I can use that information now and just sub into my formula. I've written down my formula from my log tables, labeled what each part of the formula is. Now I sub everything in brackets. The base is 14, and the perpendicular height from that base is 8. So I can sub all of that into a calculator, and I get 56 units squared. 56, and it's a size of something, so I'd say units squared. Don't know what the measurements are in here, but they're in some units. I have 14 units and 8 units, so I have area of 56 units squared. Now, how would I find the height, the h that's labeled here? Well, now I know the area and I know the base from this perpendicular height. So what I could say is, well, I know the area is equal to 56. I also know the area is equal to half the base times the perpendicular height. So I write down any formula I know that might help me with this. And then I label all the things I know. So the area is 56. The base that I am dealing with for that height would be 10. So the base is different now because I'm dealing with a different perpendicular height. So the 10 as the base would be the perpendicular height that I am looking for. So I'm looking for the h, which is going to be the h perpendicular in that formula. Well, I see I have a formula and I could sub into that formula. So I'm going to try that and see if it gets me what I need. I have 56 for the area. It's going to be a half times 10 for the base times the height that I'm looking for. Everything in brackets. I can multiply half by 10 and get 5. So I have 5 times the height is going to be 56. And now I just need to divide both sides by 5. 5 divided by 5 would give me 1. So that would give me 1 of the height. And when I put that into my calculator, I get that that is 11.2. And that would just be units. Not units squared, because it's just the height. It's the perpendicular height away from the base of 10. Now, what can I do with my parallelogram? Well, I'm immediately asked for the area. So what piece of information would I need for the area of a parallelogram? Well, I know the area is going to be the base times the perpendicular height. And I can see that I have a base of x and a perpendicular height from that base of 10. Well, I don't have enough information there, but I have a base of 8. And from that, I have a perpendicular height of 5. Again, the perpendicular heights can be given off to the side of the diagram, or it could be given in the middle. I just didn't want to put lines going in multiple directions inside the shape. So we can see it out here sometimes as well. So I can see I have a base. If I have a base of 8, I have a perpendicular height of 5. So I write down that information. I know that if the base was 8, my perpendicular height from that base would be 5. So I sub into my formula there, and I say the area is going to be just 8 by 5. So my area is going to be 40 units squared. Again, dealing with an area, I'm going to have units squared. Whatever I'm measuring in, the area would be units of that squared. Now, how would I find, sorry, that should say x. My apologies. How would I find x, the missing piece there? So the way I'm going to find x is I write down what I know about this shape. Well, the only formula I know for this shape is my area formula, so I write down that formula. If I knew any other formulas, I'd write them down too. And then I'd write down what I know. Well, I've used the 8 and the 5 there, but I can also see involved with this side that I'm missing, I have this perpendicular height of 10. I know these sides are the same length, so if this side length is x, then this side length here is also x. So this is the base, they're both the same base for the perpendicular height of 10. So the bit I'm looking for would be a base. So the base would be x, and if the base was x, then the perpendicular height would be 10. And I know that the area is 40. I just found that. The same shape, so the area would still be 40 units squared. So then I can just sub into my formula and see if I can make progress. So 40 is equal to x for the base times 10. Well, that means that 40 is equal to 10x. And I want to get x by itself, so I need to get a tenth of that. I can't like subtract 9x's or anything, because that would make x's go over here. So the only simplification I can do is to divide. So I end up with x must be equal to 4. And that would be 4 units. I should have units written in there. So that's how we approach these questions. We write down any formulas we know for the shape that we are given. At this point, we're just talking about area formulas, but we can know other formulas about shapes as well. Then we label any information that we know, be it the area or bases or heights from those bases. We sub into the relevant formulas and we see if we can make progress from there. And if we follow that setup, then we'll be able to do what we need for our triangles and our parallelograms. And that is what we need for now.